Hello, fifth graders. Happy Monday. I hope you all had a fabulous spring break. Just a reminder that this week, our week of distance learning, we will be distance learning Monday, Tuesday, Wednesday, and Thursday. Friday, there won't be anything because it is Good Friday. That's a day off from school. Then we have Easter weekend next weekend. And then we do not have school on Monday because it is Easter Monday. And then we will be returning back to in-person next Tuesday. So, like I told you guys before spring break, for math during this distance learning week, we're actually going to be doing videos instead of doing it in person. So make sure you are logging into or getting onto our Zoom call at 10 o'clock, our class Zoom call. That is a time when you can ask me any questions you have about math, about reading, about anything. So I recommend if you know there's a subject you usually have questions about, I would try to get at least that subject done before our class Zoom call. That way you can come onto our Zoom call and ask me any questions. Now, that 10 o'clock a.m. Zoom call, that's the only mandatory one you have to be at. I also have 2 office hours, one from 8 to 9 a.m. in the morning, and then one, I believe, from noon to 1 in the afternoon. And remember, those are voluntary only if you have questions. You can hop on, ask me your question, then hop off and get back to your work. So let's get started with math. Today, we are starting a brand new unit. And so at the top of our notes, you should have your math notebook open up to your next clean page. We are focusing on topic 10.1, which is all about volume. And we're going to talk about what volume is here in a second. So we are titling our page 10.1 Model Volume, and we are writing today's date, which is 3/29/21. Can you guys believe we're almost done with March? That's amazing. It's crazy to think about. So fifth grade, if at any point during this video you need more time, pause the video, finish up the part of the notes you need to finish up, then you can press play. And the same goes if you know how sometimes if you're reading and you read a whole paragraph, then you realize, oh my goodness, I'm not even sure what I just read. If that happens to you in the video, pause the video, rewind it a bit, and watch it back again to make sure you understand what I'm saying and what I'm teaching. All right, so I'm going to move on. If you need more time to get your header at the top and the date, pause the video. So first thing we need to answer, what is volume? And notice I put volume. I put kind of like a spiky circle around it in yellow highlighter. So what is volume? Well, volume is the amount of space inside a 3D or a solid 3D figure. The amount of space inside a solid 3D figure. Let's go ahead and get that written down, and then I'm going to explain to you what I mean. So volume is the amount of space inside a solid 3D figure. All right, so you might be thinking, well, Missy, what are you talking about? I want you to think about a box. And so here I have a Scotch tape box. Now, we've worked a lot with area, right? So if we're looking at this from this angle, we see one side of it, don't we? We just see this. It's probably a square. I don't know exactly the dimensions, but it's a square or for sure a rectangle. Now we know if we want to find the area of this square, we would take the length times the height, right? We take its measurement going left to right by its measurement going up and down. Well, with volume, we're finding how much can fit inside a solid 3D figure. Now, this box is 3D, and what makes it 3D is the fact that flat objects, here, are Post-it. This is a flat object. It's 2D. We call it 2D because it only has 2 dimensions, and those dimensions are, length and height. But when we have something 3D like this box, we're adding a third dimension onto it, and it's this one here. Because we have the length at the bottom, the height going up and down, but then when we add a thickness to it, we call that width. So this is why it's a 3D figure, because it has 1, 2, 3 different dimensions, whereas our Post-it here only has 2. It has a length and a width, but there is no thickness, right? There is no width. So that's the difference between a 2D and a 3D figure. So when I talk about volume, I'm not talking about how much we can fit on top of this box. I'm talking about what is the measurement for what I can fit inside this box. And you might think, well, Miss E, isn't it the same as area? No, because if I go back to my first example here, we could find the area of the front part of this box with Post-its. And if that were the case, I can fit 1 Post-it on top. And in fact, it's actually too big, right? But if I open up my box and I want to see, okay, what's the volume? How many Post-its can I fit inside this box? If I go to put my Post-it inside the box, I can shove it in there. I've fit 1, but can I fit more than 1? Yes. So while I can only fit 1 on the front of this box, which that just measures the area, when I want to find the volume or the amount of space inside of a box, it's different. I can actually fit more Post-its in there. So when we talk about volume, 5th grade, we're talking about filling up 3D objects. And so we are mainly going to be working with rectangular prisms, and I'm going to explain to you what that is in a second. It's basically boxes. Thinking about how much can fit inside of a box. So, how do I find the volume of a 3D figure? So we know that volume is the amount of space inside a solid 3D figure. But now you're probably wondering, well, how do I find the volume? Let's go ahead and get that written down. And again, make sure you're pausing the video if you need more time. Well, 5th grade, there are actually 2 ways to find their volume. Now, these 2 ways I'll be showing you, they work for rectangular prisms. And all that a rectangular prism, it's a 3D rectangle. So again, this box, it might be a square, but it's for sure a rectangle. Finding the volume of a box like this. So we are working with rectangular prisms, and that's just a fancy way of saying 3D rectangles. And there are 2 ways to find their volume. Now, as you grow older and wiser and are learning more things, you will eventually, in other grades, find the volume of different kinds of 3D shapes. In 5th grade, though, we focus primarily or mainly on rectangular prisms. We're not going to be going into cones or pyramids. We're going to focus on basically boxes, 3D rectangles. And so with 3D rectangles, there are 2 ways to find their volume. Now, 5th grade, I've taught volume for a good number of years. So my ability to draw out a rectangular prism, I'll say, is pretty darn good. So in our notes today, we are drawing rectangular prisms. I want to show you just an easy way of how I like to do it before I show them to you. So again, if you're still writing down how do I find the volume of a 3D figure in the little explanation, please pause the video. If you're ready to practice really quick off to the side drawing a rectangular prism, then let's keep going. So 5th grade, when I do that, what I like to do is I like to draw the front of it first. So for example, take the Post-it out of this box. If I needed to draw this kind of a 3D or a rectangular prism, I would start with drawing the front shape. And in this case, it's a square. So I would start by drawing a square. And again, 5th grade, is it okay if your square actually is a little bit of a rectangle? Yes. For some reason, when I need to draw a square, I always make it longer than it needs to be. That's okay. These are notes. We label the side lengths usually anyways. So now that I've started with my front shape, so go ahead and draw out your square, your rectangle. Then, this is where we add our third dimension. Because we have our length and our height, now we need to add that third dimension, the width. So what I do is I come to my top left corner and I kind of make it slanted like this. Now, I know some of you, I've seen you draw them, you like to do all 3 of your slants at the same time, but it can be hard to make it look very realistic. So what I like to do is I like to draw the first slant and then I draw a straight line across, almost like too far, kind of like that. And then I come to my next corner and then I draw my slant, kind of trying to go at the same like angle or diagonal as that one. And then anything that's left over, like I have here, then I go ahead and erase it. Make this line a little darker. Then, just like how I did here, I drew the line first before I did the slant. I'm going to do the same thing here going down. So I'm going to start at the corner. I'm going to try to draw straight down. And then see how this corner, it's slanting up and to the right? That's what I want to do with this corner, up and to the right. And then I erase whatever is left over. Oh, that's not a good erase. There we go. So that's how I like to draw mine. Now today we'll also be seeing some cubed rectangular prisms. So what that means is it looks like it's made out of cubes, and really all that you do for that 5th grade. So let's say I want this to have like 3 rows of cubes. I draw one line and a second line. Again, I always start on that front shape. So I've got my 1, 2, 3 rows, and all that I need to do to make it look like it has 3 rows going all the way around is I come over to the bottom of this line, and it just needs to match up with these 2 lines on the side here. So I slant it up and to the right, and this one up and to the right. Suddenly I have 3 rows. Now let's say I want it to be broken into 2 columns. So here and here. Then again, starting with the front shape, the front square, I draw one line down the middle. Oh gosh. There we go. And then looking at the top lines here, they're slanting again up and to the right. So this one goes up and to the right. And suddenly it looks like it's made out of cubes, doesn't it? So the way that our rectangular prism is drawn, that's going to determine how we solve it. So when I say there are 2 ways to find the volume of rectangular prisms, I'm talking about rectangular prisms where it's cubes and rectangular prisms where it's not cubes. So the first prism we drew without making the cubes, that's one way of solving it. With cubes is another. So I'm going to go ahead and show you the 2 ways, and then I'm going to explain it. So, you know Missy likes to color code, so I have color coded it a little bit. So, we have 2 methods. We have the cube method and the clear method. So, let's focus on the cube method first, and then we're going to talk about the clear method. All right, let me move this over a little bit. So, we're focusing on this one first. Now, I drew a rectangular prism that looks like it's made out of cubes. So again, you can kind of see how I did this. I started with the front rectangle shape here. Then I did my top line. top left line, I should say. Then I drew it over, and then I drew my top right line. I erased anything that was there. I did this in pencil first. Then I drew a straight line down, and then that's when I came down to this corner and I connected it, and then I erased any extra there. So I just made the prism. Then I went ahead and instead of breaking it into 3 rows like we did on this one, I broke it into 5 rows. So I drew 1, 2, 3, 4 lines in my beginning shape. Then I just connected them. 1, 2, 3, 4, just making sure you're slanting up and to the right like these 2 ones. And then what I did is I actually chose, first of all, I wanted, let's see, I wanted it to have multiple layers to it. So in this one, we have 1 layer right here. But if we look here, we have 1, 2 layers. So then all that I did for that 5th grade is I drew a line from this line straight over to that line. And then wherever my line ended there, then I connected it straight down here. So that automatically gave it 2 layers. And then I wanted it to have 1, 2, 3, 4 rows. So again, started with my top or my front shape, 1, 2, 3 lines. And then I just connected them, 1, 2, 3. And then I was done. Now, when we have a rectangular prism that looks like this, where it's drawn to make it look like it's made out of cubes, I call this the cube method. So this is when you can see cubes. As easy as that. If you can see cubes, you use the cube method. So the first thing you do with the cube method is you count the number of rows. Now, how many of you get kind of mixed up when you're asked to figure out rows and columns? It's hard for you to figure out which is which. I know I do. So you want to remember that the rows are the ones that go left to right. Okay. So first what we need to do is we need to count the number of rows. So rows go left to right. Now if we're looking at this, this is why I color coordinated it 5th grade. So each row was a different color. Because even though we have some squares up here, they're all pink, right? They're just showing the 3-dimensional shape of the cubes in this top row. So if I look, I have 1, 2, 3, 4, 5 rows. So count the number of rows, we have 5. After I've counted the number of rows, then I need to count the number in each row. Now this is why it's important that you're able to see the full 3D shape, because if you imagine us not being able to see the width here, we would just see this, right? And it would look like there are only 1, 2, 3, 4 in each row. However, because we add in that 3rd dimension, that depth, we can see actually there isn't just 1, 2, 3, 4 cubes in one row. There's 1, 2, 3, 4, 5, 6, 7, 8. Because remember, it has 2 layers. So there are 8 cubes in each row. So we have 5 rows. The pink row, the orange row, the green row, the blue row, and the purple row. And there are 8 in each row because there are 4 across, but there are 2 layers. We have that 2nd layer there. So 4 times 2, that's 8. And then all that we do is we take 5 and we multiply it by 8. And what's 5 times 8, 5th grade? It is 40. Now we'll talk about how we write out units here in a little bit. But that's the cube method. So if you can see the cubes, this is the method you use. You just count the cubes in the row, or count the number of rows and then count the number of cubes in a row and you multiply it. So 5 times 8 is 40. Now, the second method is when you can't see the cubes. Now, again, 5th grade, if you need more time because you want to get super detailed with your cubed rectangular prism, or you're still writing the steps, pause the video. If not, let's move on to the next one. So the second method you can use is what I like to call the clear method. So the clear method, you use the clear method when you can't see the cubes and can see through the sides. So what that means, let me move this up a little bit. There we go. Down here, I have an example. Now in your homework throughout this unit, you'll see both ways. You'll see some rectangular prisms that have cubes. You'll see some where you can see through them. So this is called what I like to call the clear method, when you can't see cubes and can see through the sides. And with this one, if they don't give you the cubes, 5th grade, they're going to tell you what each dimension or what each measurement is. So whereas with the cube method, we took, actually I can probably just take that off. We took the number of rows and multiplied it by how many cubes were in each row. Since we can't visibly see the cubes here, we need to know what the length, the width, remember that's how thick it is, and the height. We need to know what that is, what their measurements are. And all that we do with that information, with the clear method, is we take all three and we multiply them. We multiply the length times the width times the height, or you can abbreviate it as L, a capital L for length, times capital W for width, times capital H for height. So 5th grade, the way I draw a see-through or a clear rectangular prism, I'm going to show you really quick. It's just like I did before. I start off with the front shape, which in this case is a rectangle. I start up at the top here, make my little slant, go over, make a slant, and I erase whatever's extra from that. And then starting at that top corner, I bring it down, slant up, erase any extra from that. This eraser is not great. And then for the clear, you're basically just imagining, okay, if I can see through this box, if it is see-through, how could I see what the floor or the base of it, how can I see what that would look like? And how can I see this back corner that otherwise we wouldn't be able to see? So what you do is you make a dotted line. You start at this top left corner, make a dotted line as straight as possible. It's a little hard. Down. And I usually stop about there because the point is you make this dotted line straight down. This corner should be connecting back here because the base, that side should be connected to the back. See that? So then I kind of make a diagonal dotted line up to meet that. See how kind of now it looks like that side, that left side? Then where those two meet, so mine's right about here, that should connect to this back bottom corner. So then I make a dotted line over to there. And now you can kind of see, it's like you're seeing through the box just by adding those 3 dotted lines. So that's how I created this one. So with this, like I told you, with the cube method, they give you the cubes to count, and that's how you can find the volume. With the clear method, if you don't have the cubes, you have to be given the lengths, the side lengths, or the dimension lengths in order to figure it out. So with the clear method, you take the length, which in this case is 4, times the width, which in this case is 2, times the height, which in this case is 5. Now, what do we know about order of operations, 5th grade, when we have more than one multiplication symbol? We work left to right. So 4 times 2 is 8. 8 times 5 is 40. Exactly. So with both of these here, their volume, we get the number 40. Now you might be wondering, Miss E, what's the unit? Because remember, when we're finding dimensions, there's always a unit. When we are talking about the cube method, what do you think the unit is? Because we're talking about how much can fit inside of these shapes, remember? How much can fit inside these boxes? Well, in here, what have they drawn for us? Cubes. So this one would be 40 cubes. And now 5th grade, do you remember how with area, we would have to add something to our unit because it was a 2-dimensional figure? Because it was a two dimensions we were talking about to find area, we would put a little 2 above cubes. But are we working with 2-dimensional figures right now? No, we are working with 3-dimensional figures, 3D. So instead of putting a 2 after cubes, what do you think we should put here? Instead of a 2, we should put a 3. Yep, so 40 cubes cubed, actually. Now over here, so that's a 3. Over here, do they give us a unit? Like 4 what? 2 what? 5 what? No. So what you can do, 5th grade, kind of as just a generic unit, is actually to put 40 units, and again, cubed, or to the 3rd power. 40 units cubed. Now, let's say you forgot over here, like, oh gosh, do I put cubes or not? You could just put units since they didn't tell us. So units. Now, if they told us each cube is 1 inch by 1 inch over here, then we would use inches. But they didn't tell us that. So cubes would work if you're using the cube method where you can see cubes. If you can't see cubes and can see through the sides and they don't give you a unit, you just put 40 units cubed and you got it. Now, 5th grade, if you're thinking, okay, I think I got most of what Miss E said, but I feel like I could listen to that explanation one more time, just back up the video to whichever method you want to hear again, whether it's the cube method or the clear method. Back up the video, rewatch it, because we are going to move on to practice otherwise. So if you're ready to move on to practice with me, let's go ahead and label our practice section. So for our practice section, we need to find the volume of each prism below. Remember, a prism, that's a 3D figure, okay? To get technical, a prism is a 3D figure where the top and the base of the figure are the same shape. So we're working with rectangular prisms. So the top and the base of all of our shapes are in the shape of a rectangle. That's what a prism is. So if we were to say like a circular prism, that's like a cylinder where the top and the bottom are circles. Or if you say a triangular prism, that is a 3D figure where the top and the bottom are both triangles. It's kind of fun. But yes, we're working with rectangular prisms. So practice, find the volume of each prism below. Now 5th grade, for these practice problems, let's see, we have 3 of them. There is one that is in cubes, so you would automatically use the cube method for that. The other 2 are not. They do not show cubes. You can see through them, so you will use the clear method for them. So what I'm going to do is I'm going to show the practice problems. You are going to take some time to draw out each of them, and then I want you to try to solve them or figure out the volume of each of them on your own. Then we will look at it together and you can check your work with my work. So here are the 3, okay? So our first one, and again, you can see Missy sometimes makes mistakes with her rectangular prisms, but remember, I like to call mistakes discoveries. So that's totally fine. But here you would start with a rectangle that's taller than it is long. So I like to use the spacing of the lines on my notebook paper to help me. So I went down 1, 2, 3 lines, and then I went over probably about the width of my pinky, actually. And I just kind of drew that rectangle first. Then that's when I came up and notice I slanted it all the way up to the next line of my notebook paper. Slanted it all the way up to the next line, connect them. And again, with this bottom one here, I slanted it all the way up to the next line as well. So I knew how wide, the width, how wide that should be. Because however wide it is up here, that's how wide it should be down here as well. I connected it, and then I divided this into 6 boxes. I made sure the line that's going up and down connected with the line on my top, just slanting up and to the right. And then I made sure that my lines going across here connected up and to the right over here on the side. And then I split it into 2 layers here by just drawing 1.5, making sure that line connected with the one going down the side, also connecting it in half, or splitting it in half. So here's one in cubes, so we would use the cube method. And then we have 2 over here. Now, you might be thinking, well, Miss E, you said for the clear method, it's when you can't see cubes and can see through the sides. Well, sometimes you technically don't see through like this. However, are we still given all 3 of our dimensions here? Yes. So even though we don't see the dotted lines as if we can see through it, we are still given the 3 different dimensions. So we would still use that clear method, the length times the width times the height. And then the third one, that is one where we can see through it. So what I want you to do right now, 5th grade, is get these written out, or drawn and written out. Then I want you to solve them on your own. I'm going to go ahead and solve them. So you need to pause your video, get these drawn out and solved, then you can press play again, and you can see if you got the same answers as me. So go ahead, pause your video, press play when you are ready. All right, 5th grade, let's go ahead and solve these. So our first one, I see cubes, so I need to use the cube method. Now with the cube method, remember, we count the number of rows, then we count the number in each row, and we multiply those 2 together. So when I look at this one, remember our rows go left to right. So I have 1, 2, 3 rows. I have 3 rows. Now, the amount in each row. Remember, we always like to look at the top for that, because if we were looking at the shape straight on, we wouldn't be able to see its thickness. It's kind of like with our Scotch tape box. If I look at it just from the front, you can't really see how thick it is, right? But if we tilt it just a little bit like that, suddenly we see that width, right? How thick it is. So we need to look to see how thick it is. Well, if I look up here, I see there are actually 2 layers here, 2 layers of cubes. So that means instead of just having 2 cubes in a row, we actually have 1, 2, 3, 4. So 3 rows, 4 in each row. Well, I counted the number of rows, I counted the number of cubes in each row, and now I need to multiply them. So I would take 3 times 4, and that gets me 12. So it's up to you which unit you used. You could have used cubes or units. So 12, actually for this one, I suppose we could really just say 12 cubes now that I'm thinking about it, 5th grade, because we know that cubes are already 3-dimensional. So technically, I do think we could just say 12 cubes. But if you popped in a little 3 as an exponent, just to be safe, totally fine. So 12 cubes cubed, or 12 cubes to the 3rd power. And if you think about it, 5th grade, if we were to kind of count, you could always just count out the cubes. 1, 2, and you just need to remember each one has 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would work. All right. Now for number 2, even though we can't see through our rectangular prism here, we have all 3 of the dimensions, so we would still use the clear method. Well, our clear method says we need to take the length times the width times the height. So if I look here, they have it labeled actually, H, L, and W. So length is 4 inches. The width is 3 inches. Remember, the width is how thick it is. And the height is 1 inch. Now, what do we do when we have multiple multiplication signs? We work left to right. Well, 4 times 3 gets me 12. Times the 1, I'm still at 12. Now, 5th grade, do they tell me the unit? Yes. They tell me in the different dimensions, inches, inches, inches. So it's 12 inches. And what exponent do I need since it's a 3-dimensional figure? I need a 3. So 12 inches cubed, or 12 inches to the 3rd power. Awesome. Then finally we have number 3. So number 3, definitely the clear method because I can see through it, right? However, do they label the different dimensions for me? They give me the length, but do they tell me which is which? No. So 5th grade, this is why it's important to understand which is which. So remember, our length, that is our measurement going from left to right. Our height, it's how tall it is, so going up and down. Remember, the width, that's how thick it is. So usually our width, 5th grade, it's a diagonal line. So out of these 3 dimensions, the only diagonal line is this one. If we look back here, look, our width, it's at a diagonal, right? If we go over to the cube one, there's our diagonal again. So the diagonal line, that's always the width. So again, I would take my length, or how long it is, in this case it's 4, times my width, that diagonal line, it's 5, times the height, up and down, which is 12. So I would take 4 times 5 times 12. Well, we know that 4 times 5, that's 20, isn't it, 5th grade? I'm almost running out of space. Just going to make it. So 20. So then I need to take 20 times 12. Well, what is 20 times 12? It is 240. And now 5th grade, do they tell me what unit I should use? Yes. Centimeters, centimeters, centimeters. So 240 centimeters. And what? Well, that almost looks like this is a C, not a 0. Sorry. What unit, or excuse me, what exponent do I need since it's a 3-dimensional figure and we're finding volume? I need a 3. So 240 centimeters cubed, or 240 centimeters to the 3rd power. So 5th grade, on your homework tonight, you're mainly going to be seeing cubed figures like this. However, you may see a few that are clear, or Not necessarily clear, but you're just given the 3 dimensions like number 2 in our practice problem. I wanted to make sure you were prepared and you knew that not all rectangular prisms are going to be broken into cubes for you that you can just count the rows and how many are in each row. There are going to be, especially like in the coming days, we're just going to be working with the clear method. So just keeping that in mind. So what I want you to do for homework tonight, go ahead and in your math workbook, please take that out. You are going to open up to page 591. So go ahead, open up your math workbook to page 591. And on page 591 and 592, you are going to circle numbers 1 through 7. So that's 1, 2, 3, 4, 5, 6, 7, 1 through 7, and number 10. So I will say that one more time. On page 591 and 592, you are circling numbers 1 through 7, number 10. All right, nice job today, 5th grade. Remember, any questions you have, you can send me an email. You can send me a message in Google Classroom, or you can hop on one of the office hour Zoom calls to ask me your question kind of face-to-face. All right, 5th grade, have a great day. I hope everything goes well. Nice job.